Are we back? We're back. Okay. Oh, I am so prepared today. You can speak all you want. We don't hear you. Yes, no worries, no worries. I think we got there. The microphone is working. Good. Let's see who's here. Let's start with that before everyone says hello. Dutchmaker says hello, and then Medved says hey, Quindor. And Greg ED says good evening all. Jacco Weiss is here. Q is late for the pre-stream. Sorry, apologies. Let's see. Draadstaal says, evening all and music. Yeah, I got to attend a live stream from Holland. I am here in Canada and almost Tulip Festival. Oh, interesting. Okay, cool. Would 1200 watt of LEDs be visible from space? Well, probably, especially if you lens it upwards somehow. Yeah, I think so. No voice, no audio. Good day, sunshines. Only music. We could do an only music stream. I didn't shave, huh? Well, prepared, no. Okay, so welcome everyone. I was still scrounging up cables we're going to need. This is a 10 gauge, and I think we need to make 2 or maybe 3 more of those. So we'll start off the stream by making some cables, because then at least I know I can take the load. We might actually have to get the third load tester, because I have 2 on my desk here, but those can do 50 amps at 12 volts. So in theory, we should be able to do all the testing with 2, but I fear we might have to go to 3, but we'll see. One patient says his head is full of LED lately. Someone did a nightly stream of a black screen this week and for 8 hours and people kept watching. I'm doing something wrong. Another thing I'm doing wrong is the back wall is still the default orange. Let's fix that. What shall we do? Rain. No, we already had rain last time, I think. Boring. Try wipe. Should we now have more colors? Let's make it faster. Go. Woohoo! Okay, no. Sure, that's cool. Let's go for a different color. Excellent. Yeah, all good. Has Meanwell ever not delivered its rated power? Not in my testing. In my testing, it's always been good. But these are from AliExpress, from 2 different sellers. So, yeah, we're gonna see. Default should be pink. I don't know. Well, let's have a drink. We are going to go for a Coca-Cola Zero Vanilla, because I'm so vanilla. You're wondering what LED wall art what impact LED wall art is an average on the bitrate of the stream? Is it single-handedly costing Google money? Maybe, but actually the stream of my desk is the most bitrate intensive, because if I go to the face, my recording is actually only taking like 5 or 6 megabits, while my YouTube stream I have locked at 32 megabits. So I'm streaming in AV1 and I'm also recording in AV1. Actually, I think I want to change my recording setting because it's a bit low. Let's go to 23. There. Is that better? In theory. Yeah, my recording is a bit low. I'm not sure why. But yeah, 32 megabits to YouTube in AV1, so that's in theory the best codec. I am streaming 1440p 60, but still, that's plenty of bandwidth. I don't think the LEDs are going to influence it that much. Although, of course, it will cost extra bandwidth. That's true. Why is it so low? Maybe if I zoom in. Zoom in. Yeah, okay. It spikes higher when I zoom in. That's fine. Okay, that's fine for a live stream. I normally record in about 100 megabits of AV1. So I have like the perfect quality. With that, I can then edit, which of course is already a re-encode of everything. So the higher quality your source material, the higher quality you'll get when you encode it again. And then YouTube encodes it again. So yeah, there's multiple steps which will degrade your video quality if you don't keep it at the highest quality until the last step, basically. You can always be a hand model if the whole LED thing falls out of favor. You think so? I don't know. I didn't cut my nails, though. I'm going to get comments about that again. Like, many years ago, I made this video and this guy commented like, "Great video. Too bad your fingernails were so long. Gay." And I'm like, "You have a problem with gays?" And we got a whole discussion about that. This idiot was really stupid. Anyway, you hear those YouTube channels are being auto-banned by Google AI. Oh no, all the AIs. Your stream has always been very good quality visually speaking. Yeah, I try. I have like really... Oh, okay. These cameras, these are Panasonic S5 IIs. So they're... How much is a Panasonic S5 II? I bought them both secondhand, I think. Let's see how much a new one is. A new one is $15.99. So those are not cheap cameras. €15.99, but yeah. I have two of those because the top cam is now also one. I had an S5, not the 2 one before, but now we have two S5 IIs. But I tried to buy them secondhand or during like Black Friday or something like that. So those are $1,500 a piece. And then the lens on this thing, on the top one, is $1,400 because it's a very special lens. Because if you've ever noticed, I can zoom fully out and fully in, and the lighting doesn't change. So this is a 24-105 with a fixed aperture of, I believe 4. Anyway, the clue is that it has a fixed aperture. So if your aperture doesn't change during zooming in and out, you also don't have to adjust the lighting. And that makes it very important for a top lens, which I zoom in and out with constantly. So that I always know the settings are correct. Because I have everything on manual settings. Manual, well, okay, autofocus, but manual exposure, manual aperture, etc., etc. Yeah, and the lens here in front is a prime. It's a 24mm prime. Yeah, so no zooming. But then you get, in theory, you get the best quality, right? And I can create a bit of shallow depth of field and blah, blah, blah. It's an f2.5 if it's correct. But, yeah. Because, you have the background a bit blurred. And, yeah. But I like audio-visual stuff. It's all being piped into my PC using HDMI. So I have an optical HDMI cable on the top one, and this has a normal one. It's all running in 4K 60 to a quad capture card from Blackmagic, and yeah, I like the results myself, and that's the most important. Well, it's an f1.8, but I set it to sorry, I set it to 2.5. Otherwise, the shallow depth of field is a bit too much, and I also like the 60 FPS. It's not 60 FPS. Why not? Oh, there we go. Sometimes it doesn't 60 FPS. I think it has something to do with the focus or something. I don't know. Not sure. My Suzuki trying to find an RGB CCT IC strip. Is W2805 the best? I see Newell Dual IC RGB CCT WS2811, but people say it doesn't work with WLED, only SPI. They're trying to copy GoV2. Okay, so WS2805 in theory is the best because it has the best specifications, but you're stuck with a wider strip. It'll be at least 12 millimeters, but most of them are 15 millimeters. If that's not a problem, get those. Those are great. The dual WS2811s do work with WLED. I've demonstrated that on the stream. You need to select the FW1906 profile in the LED preferences. But you need to look out for that it probably has a bit less zones. So you need to see the cuttable length of each strip, and that will determine how many zones you have per meter. Yeah, 1.8 is nice, especially for some photography and other stuff. Yeah. But that's why it's a prime. You know, you give up the zoom and you get a shallow depth of field. What? Quindor's hands are so nice. I'm a lady and mine hardly compare, says Jane Anderson. Aw. What's going on over here? Okay. Sure, no problem there, Might Suzuki. I do a lot with LEDs, so you know. Oh, it's 2118. I get to work on my cables. Because we're going to be testing LRS-1200s today. Those are the newest LRS type. We'll start with the 12. I have a 12, a 24, and a 48. Let me put them on the desk. So we have a 12. A 24. It's not secret time yet. No. So we have a 12, a 24, and a 48. And they're fairly big power supplies. I have an LRS-600 here. But actually for the capacity, they're pretty small. Because this is an LRS-600. Oh wow. It's exactly the same size. What? Okay. I thought they were bigger. No, it's exactly the same size. Look at that. Cool. Yeah. Except that this one has a fan over here and it's bigger. And the 1200s have two fans over here. And it's going to be interesting to see how much noise they make. We'll see that during the live stream. Wow. Okay, so they fit two times as many watts in the same footprint. It's bigger inside, according to Doctor Who. Yeah, but that's really impressive. Although there is something of note, if you're looking to purchase one of these. Let's zoom in. You do need to note that this is a 200 to 240 volt supply only. Now that is likely because it will draw 7 amps on the AC side, which is a huge number. And thus probably 110 volt would be too close to blowing the circuit basically, right? It does say 270 volt 5 amp for North America only, but I don't know how that works in the US. So yeah, maybe you need to have 2 phases then or something like that. I know their electrical systems work slightly different. Yeah, but the 12 volt will output 12 volt at 92 amps. Now you'd expect it to do 1,000 or 100 amps, but for some reason it's limited to 92. Well, okay. There we can go to the 24. It also does the same, but then it outputs 24 volt at 50 amps. Very nice. And then we have the LRS-48, the 48 volt. We will do 48 volt at 25 amps. And I'm going to see how high we can push this. If the 48 volt could maybe also go up to 55 volt. I'm interested in knowing. So we're going to check that out too. And we got these little cables with each of them. because there is this connector here, and we'll have to look in the manual what those are for, but it could be that we could use those as a sort of integrated relay feature, right? But we'll have to look up the manual. Well, we can do that first, and then I can make some cables, and then we can test it. Is there a power restore option on the DigX boards? With the WLED power restore does not work consistently. Mostly not. Have occasional brownout that leaves a lot of LEDs on. Who? Maybe one patient. We'll do some thermal measurements. I don't know if it's actually going to be cooler or not. Brownouts. You're having brownouts? So I don't know what dig control you're running. The DigNext 2 has a extra feature where it will cut off the power to the LEDs themselves, so that would prevent some staying on. And otherwise, you can, on a Dig Uno or Dig Quad, you can use a relay for that and 2 power supplies. So that might be interesting to look into. Mean Well. Well, it has the lowest amp draw, sure, but that doesn't say the power supply will stay lowest. Yeah. So let me find the PDF. Oh, it has very high efficiency. Interesting. Okay, let me show you my. Let's see. This one? No, this one. Okay. Why is it like that? Nope. Okay. So it has 180 to 305. Okay, so it can take a very high voltage, probably for the US market with the 277 volts, 12 volt, 24 volt, 36 volt, and 48 volt. The older version is the SE. I also have one of those actually, 1200 I think, not sure. But the efficiency is pretty high, and the 48 volt is the most efficient, 94%. That is quite high. They would have to have upgraded circuitry to get that efficiency, because otherwise you wouldn't be able to fit it in the same chassis, right? So I'm not sure it's active PFC though. It has remote on-off control and remote sense, DC OK, over voltage category, okay. Short circuit protection, blah blah blah. Yes, give me the PDF. How does the pins, the extra pins work? So we have the LRS-1200, low profile, economical, enclosed type power supply. Okay. So sorry, no US, but yeah, 94 is high. 94 is good. Oh, well, you also have a 36 volt. Okay. Peak. Rated power. Oh, okay. So it can peak even higher. So it's rated for 92 amps, but it can do 5 seconds of 138. Holy crapperoni. Oh, and these can actually do 1800 watts for 5 seconds. Okay. Oh, nice. The voltage adjustment range is 48, so you can't lower it, but you can up it to 56 volts. All right, cool. Ah. Okay, so it has a power factor of 0.95. So these are very, very likely active PFC, right? That is nice. Again, they kind of have to do that to make sure they can get the efficiency in this same chassis, right? Because they can't generate the same amount of heat. Or the fans would have to be even louder. Remote control. Power on. Power off. By external voltage. That would be nice. Sounds like dyno test numbers. Well, we're going to test our own numbers today. 10% load, 45 dB. 70% load, 53 dB. We'll see. Intelligent fan speed control. The old one said that too. I don't know. Right, so okay. External auxiliary power. Power on, S-way open or keep 0 to 0.8 volts. Power off, S-way short or keep 3.3 to 10 volts. Yeah, okay, that's perfect. That is actually fully compatible with all the dig boards, including the dig next and stuff like that. So then you don't need a relay anymore. You can just use this feature in the power supply itself to turn it on and off. Yeah, that's an excellent choice, Nicolab. I also have an LRS-1200 in my rack for 48 volt stuff, because the stupid other power supplies kept dying, and this one's been running for years and years. So okay, so the DC output terminal, this is also important, are M5. Okay, so on the Power 7HC, do I have one here? No. No, not close. On the Power 7HC, they're also M5. So that's going to make a great pairing. Cool. Yeah, I like this. The remote control is fully compatible with the boards. So that's really nice. Very easy to hook up. Yeah, perfect. Okay, let's put that away. Is the music just gone? It's just very low. No, the music is gone. Why is the music gone? Oh, there is no music in this scene. Oh, okay. There. So, I already have one cable, and let's test if that is compatible with the LRS. I would think so. And then we need to make one or maybe two more. So you've got these giant studs. Right, so you don't have normal terminals anymore. You get these blocks, and you have this screw with washer and stuff like that. And you basically have to jam it in between there or over here, depending on what works well best in your chassis. And we're going to first try and use these fork crimps. I like using fork crimps, and I think these will fit M5 just fine. This is a... It says it right here. This is a 10 gauge cable, so that's quite thick. So let's hope that's able to carry the approximately 50 amps we want it to. It's probably a bit thin for that, but you know, for just testing, that's okay. And I'll use silicone cable. But let's see if we can get this on here. Yeah, that is actually a really, really good fit. If it would focus. Yeah. Yeah. Oh, okay. Yeah, that's no, I'm just trying the cable shoe. So that works. The problem is though, especially for the 12 volt version with 92 amps, I'm gonna need two testers at least, maybe three. So we'll have to try and get two cables on here. Let's see if we can make that work. It's maybe not the recommended way. Can we do it like that? So I kind of jammed it under there, but it can't reach far enough. But Well, as long as it's making good contact, it should be okay for testing. Right, because all the surface area is contacting, and of the upper one also. Now, the current for the top one will have to go through the bottom one. It's not ideal, but I don't know if I can find full copper expansion bars needed. Well, yeah, you could actually do that. Could we use a second screw? That's interesting. Because I have multiple anyway. So what if I take this screw and put it in here? I think it's going to be too long. Yeah. Damn it. Okay, so we might need to get some shorter M5 bolts. And I don't know if I have those. But you can't screw in both at the same time, because this one can't go in any further. Right? But if you got a shorter one, that should be no problem, because there is enough thread there to, to hold it securely. So let's see how long this is. Okay, let me do a proper measurements. If I can get this off. Okay, I can't really get the washer and the thing off. This is, I'd say 11 to 12 millimeters. Yeah. So if you'd get a 5 or a 6 millimeter, that would still allow it to travel deep enough into the screw terminal. And then you could use both of those points. Right? And that would be ideal, because then you can have two cables. Yeah, I think that I would like that. I need to check on a Power 7 HC how long my screws are. I don't think they're that long. Let me check. Do I have a Power 7? Well, I do, but I don't know where. So I believe mine also have M5 screws. So can I take this screw? It's also going to be too long. Maybe if I use two. You just need more washers. Yeah, that's also an option, I guess. I mean, the current isn't going to go through the washer, or you shouldn't make it go through the washer. But so let me move this. Okay. So let's first see if I have the right screw. I do. So my Power 7 HC screws are, yeah, well, basically the same. And now let's see if we can fit them both in there. Oh, barely, almost. Maybe if I just... No, I'm starting to bend it a little bit. So, see that? They're touching. Okay. Well, a larger gauge wire isn't going to change how much my load tester can handle, or yeah, how deep the screw will go into the terminal, right? So, no, I mean, and let's see how long these are, because these are almost the right length. Can't get those off. Okay. Yeah, these are 10 I'd say. So if you use 8 or even 6 millimeter, I think you're still going to get plenty of bite on the terminal. And yeah. But I'm glad Meanwell and I agree on what you need for 100 amps. Actually, in my case, we're doing it over 2, and in their case, they're doing it over 1. So I guess I'm a bit more precautious. Yeah, M5 is a decent, size. I like it. And yeah, for the Power 7 HC, it just made sense for using M5s. And I use these studs, which have like 3 legs on each side. Oh, you can see it better over here. 3 legs here on each side to go into the PCB. So you have 6 legs. Yeah, that's going to carry plenty of power. And the way they do it is they don't actually use the legs. Looks like they have a copper island. And they screw it in from 2 places. So they screw it in from the back. Yeah, you can see the screws over there. They screw it in from the back, and then I think they solder it onto the plane, basically. Right? And that's also going to give a great connection. It's more prone to cracking, maybe. Yeah, I guess they would have thought of that. Yeah, well, it's also a nice system. Yeah. Okay. Anyway. Yeah, good connectivity. Yeah. Yeah, I use the 6 legs. They use a plane. All good. It's in the end, it's all about surface area, right? You need to have enough surface area to transfer the current. And 100 amps is a lot. So, yeah. Okay, so this cable will work. It already has the right end. We'll need to make at least 1 more for 2 testers, and then we'll see if we have enough. But that shouldn't be too hard. Let's see how long this is. This is long enough. I don't have a huge amount of 10 gauge, but I have some. I generally just use it between the power supply and the board, or something like that, right? So I don't need a large amount. I have a lot more 12 gauge and 16 gauge. 100 amps is a lot if you've never worked with 12,000 amps. Yes, that is correct. Okay, so from here we need about something like that. Oh. Takes a bit. You use 8 gauge for speakers. Okay. Is it doing like 200 amps on your speakers? So I always cut these in the middle like that, because it kind of auto guides the scissors. And if you try and tear it, you often tear into the shell of the silicone. It tears open. But if you make a nice cut, it generally goes perfectly. And a little bit more here. $1.0 for sub amps, but how many watts are we talking here? That's insane. And is it copper or something else? Right, so let's see if we have the right, and we should. The 5.5-5 should be good. Oh, I also have 8-5. Okay. Thousands. Okay. Okay. So let's see if this is the right one. I think so. Yeah, that fits under there perfectly. good. Now we only need a little bit. We need one of these crimpers. So, and then we use the largest version. Okay. Okay, needs to poke out a little bit there. Let's do 2 crimps. Yeah, I could have had it poke out a little bit more. But that should be a decent crimp. Yeah. Okay, yeah, that's not going anywhere. Okay. Car audio math is a different science. Okay. Sure. Oh, sorry. So let me show one more. There. That one's a little bit better. Pokes out a little bit more at the end, but in the end it's most important that, you know, the clamp squeezes around there. And it's nice and tight. Ohm's law is the same though. Yeah, true. Okay, now we need one of those speaker thingies. I like using these because we tested them in a live stream and we were easily able to push 50 amps through them. Hey there, Josh. Oh, I need the tool. I have that here. Nice, Stuart. Glad you like them. Okay, so let's undo these. Yeah, we can do them both. Okay. So let's see, we need to strip a lot because I want to double fold it basically. So let's do that. Oh, I didn't do it. Okay. Can I? Sure. Okay, the other one. No, we'll check first. So what I like to do is twist it a little bit and then fold it double like that. And that should allow it to go in here fully basically. And we get a good surface contact. Let's lock it in there. Are you able to discuss USB 4, PD 3 and 4? I haven't heard of PD 4 yet. What's new with PD 4? Because PD 3.2 already goes to 48 volt 5 amps. And USB 4 is more of a Thunderbolt aligned protocol, I guess. It's a bit different, but basically the same capabilities. Okay, nice and tight. So that's not going anywhere. We have a little bit of spillage, but that should be making plenty of contact in here with all the metal chamber. Yeah. There. Okay. I want a bit more inside there. Okay, didn't do this too nicely. Let's see. Okay, good enough for me. There, that is locked in there tightly. Okay, let's disconnect whatever is in there right now. Add some 18 gauge in there. Looking for 100 watt PD. I know they make lots of power supplies to make this power, but can I just use a Meanwell with a barrel jack to supply for a pencil V2? Well, first of all, don't use a barrel jack. Anything above 1 to 2 amps, unless you have, it's going to be, you know, too high resistance. And PD is generally 20 volts with 100 amps. No, wait. 20 volts with 5 amps. So you're going to try and push 5 amps to that, and the connector often isn't really suited for that. Maybe in the pencil it is, I don't know. But most barrel jacks out there really aren't meant for that purpose. But I don't know the circuitry in a pencil V2, so I don't know what to say there. Okay, let's start with our 12 volt. One moment. Okay, so now we do need to pay attention what plus and minus is. we need to connect at least 2 cables. So where's the other one? We're gonna try that same trick again. Okay, now I need a bit better access. So we're gonna do this one upside down, and this one like this. Okay. I wish I could have gotten 2 screws in it, but I can't. Not right now. Okay, so let's torque that down nicely. Yeah, okay. I'll show you in a minute. Now let me do the next one. Okay. Oh, Okay, let's see if that's making a decent connect. Oh, okay. No, we need to do the negative side again because it got pushed out a bit. I know you can see, but are we attempting to melt something? Yes, the power supply. Nice. Okay. Okay, let's see if that's better. Oh, I think so. Yeah, this is a pretty good sandwich. Can't pull it out. Yeah, this is far from ideal. I don't think this is the way to do it. But okay. For now, it'll suffice. Right? Let me screw it in on this side, and then we can do the AC side. Hey, no worries, Greg. Too many cables. More too many cables. Okay. Okay. Good. Yeah, we can keep it over here. Let's take a look at the AC side. Those connections are going to loosen. Well, for now, I can't really move it, so it's good enough. Here we're also going to cheat a little bit because I don't have any with forks on there right now. So we're going to use these, but these are well nicely flattened. Sure, Greg, no problem. No, if this was permanent, I would advise to order an extra or two, basically a set of new screws. And I think then you can use the top one and the front one, and you can get some very nice connections. But even on the AC side, we're talking 7 amps. So, I mean, that's not nothing. Well, sure. It wouldn't give me that much more space, and this one is pretty tight, so not sure that's all. Okay. This is plugged in. Let me turn this on. Good. Let me turn this on. No. Nobody said anything. Oh, unneeded said something. Good. See, you were needed, unneeded. I know it doesn't really matter and it's AC, but better to do it right if you can. So Earth neutral live, good. That's good. Power, and let's go to the. Oh, it's immediately making noise. Intelligent fan control. Where is it? Okay, it's drawing 9 point something watts. Okay. Good. Yeah, so intelligent fan control might mean always on? I don't know, man. I would have expected it to start while off. So we need to get this bugger connected. I recently emailed them for new firmware. Didn't hear back. So, where is it? Okay, I need to enable the Wi-Fi. Thermal tools. Do they have an update? We always update during the stream. No update. Okay. Failed to connect. Let's, I don't know, hit more buttons. Oh, that did it. Okay, stupid window won't resize. Fine. Let's see, this guy? No. This guy? Yes. Okay, that should be good. Let's see. Oh, the macro is still on there. Let's see here. Yeah, there's my camera. There's the other camera. Okay. So here's the power supply. Oh, there's already something hot over here. 60 degrees! Yeah, I think it's these two flaps here. No, we haven't checked yet. Okay, so let's try and open the software for the loads. Now, I'm not going to mess with trying to get two loads working at the same time, because that generally doesn't work. So we'll start with one, and then the other one I'll do manually. I'm waiting for the software. Okay. Let's see if I can enable that. I can. Now I need to move this. Okay, and now we can immediately see the voltage. Yeah, sure, those heat cycles. Yeah, of course. No worries. I mean, if you can use a ring terminal, that would probably be even best. So the output voltage is 12.13 volts. That's perfect. Let's start off strong with 45 amps. Yeah, we're just going to go for 45 amps. Go. Oh, look at that power factor. Well, we can see our cables are pretty decent because we're doing 45 amps and the voltage has dropped from 12.1 to 11.5. So that's only 0.6 voltage drop, well, over with 45 amps. Now we're using 10 gauge because of that reason, of course, but yeah. So what I worry about is that the CPU or MOSFET temperature is probably going to overheat if we do actually 50 amps, but we only need to do 92, so that's 46. Oh, that's 46. Okay. Is it no? That's 82. No, what? Mathing? I can't math on stream for some reason. 46. I am correct. Okay, so let's set it to 46. Okay, well, all good. So we're pooling 528 watts, and we're getting, or the socket is delivering 592. If we convert that, so 591 divided by 528. No, other way around. 528 by 591. That's 89% efficient. Okay. Yeah, right. Okay, lack of faith. Faithify? Sure, yeah. I mean, we can see how warm this is getting, although it's metal, but if it's a bad connection, the cable will also heat up. And currently the cable is 41 degrees. This one is 45 degrees. Yeah, I'm not too worried about that. That's fine. Datasheet says 91. Okay. It's not making that much noise, I have to admit. Yeah, it's moving a decent amount of air. Yeah, thermal camera on this kind of stuff is kind of, you know, we can check the fans. Yeah, you can see where it was on the desk. Sure. Okay, let's add the other one. And I'm immediately going for 46 amps. Go. Okay, we're now doing 2 times 46 amps, so that is basically the maximum rating of this power supply, 1200 watts. Well, okay, that's not 1200 watts, actually. 92 amps at 12 volt, how much is that? That's 1104 watts. Have to be correct here, because we're not able to do 100 amps according to the specs. Look at those holes in the top, okay? Yeah. Sure. Now things will probably get a little bit warmer. Something over here is getting warm. So these ICs here, I can do the macro. So there's those ICs. But it's something over here. Oh, you can see the copper planes in the PCB. See that? So there's some kind of plane there. Probably the negative side, I'm not sure. That's heating up now. Well, burning up. I wouldn't say 66 degrees with air over it. Uh-oh. Okay, one of my testers has gone into over temperature. I was afraid of that. So let me turn it off and off. Yeah, cables are getting nice and warm. Hey, Philip! Cables are getting nice and warm. Okay, so both testers are currently off. Let's give them a little bit of time to cool off. You can see the MOSFET temperature here. Sure, yeah. What's going on the barbecue? We have some Meanwell LRS-1200s. Yeah, so we'll give the testers a bit of time to cool off and then we'll try again. But I mean, we suddenly added about 50 amps and it didn't give a flying F, so I'm not too worried about it. They'll yeah, maybe, we'll see. That's not really how it works there, Matt Solomon, because the amount of power you can deliver to the LEDs depends on how many power injections you have. Let's say you only have a single power injection at the front, then you're limited to about 4 amps. It doesn't matter if you have 100 LEDs or 1,000. So, yeah, we might need a third load tester. I don't know. I'd rather not, because it's a hassle to set it up. But, yeah. And I don't know really how to connect the third cable there. The air temp coming out of the fans. I can't really measure air temperature. I can only measure it like this. And you can see that the desk got warm, but later, Josh. A three-way outside. Yeah, no, that's going to be a bit too much, I think. Okay, the testers cooled down to 46, so I'm going to hit it. That is 1. That is 2. Yeah? Let's go. Cool, okay. So that is 527 times 2 divided by 1194. Is that about correct? Yeah. Okay, that's 88% efficient. Now, that is including the voltage drop we're getting from the terminal to the testers, right? The power supply is actually generating more than this efficiency calculation, but because we have cables which are losing power, burning it up, we're not calculating that, but of course officially it's still generating it, right? So I think it'll actually be above 90-something% in reality. Yeah, I mean, cables are getting warm. 40 degree-ish. It's okay. Exhaust isn't really hot at all. You can see where the hotspot was on the table. Let me turn it around. Yeah, it's metal, so it doesn't work like that. Yeah, no, that's not going to show anything. Okay. How's the testers doing? Yeah, you can see the cables here, pretty getting nice and toasty. And the back of my wall is being blasted with heat. But yeah, we're doing 1200 watts or 1100 watts output for a while now. Tape, yeah, I'm not going to tape in the whole bottom. It's cool that these are the exact same form factor as the LRS-600. Because for the Dig Octa, including the Power 7 HC, there's some 3D printable mounts you can make for that, for the LRS-600. And that will immediately be compatible. And then you can just loop 2 wires from here, short wire. Perfect. You got a 100 amp power board there. I think you could better get a heat pump one patient. It's going to be more efficient. Oh, one tester overheated. A second tester overheated. Nice. Oh, it's immediately on again. Okay, let's turn them off. They're beeping at me. We are desoldering our own MOSFETs. Okay. You just dismantled one? What? Oh, a heat pump? Okay. Sorry, everything is making noise here, trying to cool off. The room is getting noticeably hotter, so I am pumping like 1200 watts of heat into the room, so, you know. Oh, your parents got a new AC, yeah. Now, this isn't a big room, right? So, 1200 watts of heat is plenty to warm it up. So, we could do try a little burst load. I'm not sure I'm allowed to go above 50 amps. Let me check. No. Oh, I can. Okay. Let me try. Current assembly power 50 amps max. Oh, okay. Aw. Okay, it doesn't like 55. We can do it 2 times 50. No. Okay. Let's wait for it to cool off a little bit more. So we're going to overdraw it with 8 amps. If you're getting these to be quiet, I wouldn't do it. Okay, let's try it. I'm gonna turn this one on first, and then this one. Okay, 100 amps. Power meter is like very confused. Okay, 1300 watts. We're drawing 6 amp from the socket. Power factor of over 1. That is impossible. Yeah, I haven't calibrated these numbers yet. Actually, I should do that now. Wait. So 1303 on there is 1314. Okay. Okay. 302. Okay, 302 is 1314. Sure. There's a little bit of ringing or something going on. Not sure. It's probably just the fans that are ramping up more. If I now move it, you can see where the hotspot is. It's actually doing this longer than I expected. My testers are going to overheat again. Yeah, all good. Cables are a bit toasty. 49 degrees, 50 degrees on there. Yeah. Can you imagine? We're pushing 10 gauge to 50 degrees. Yeah. Okay. All testers are mad now. Okay. 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 All testers are off. Let's see how quickly it quiets down. Yeah, I can hear the fan pitch change already. Is the heat moving through the positive or through the negative? Well, the power supply direction, the air is flowing from this side to this side, so it's pushing air through that way, which is good because the cables, I guess, also get a bit cooled. The unit is actually still fairly cold to the touch. Bottom side, it's not even hot, it's warm, right? The direction of heat moving to the cables. Well, generally the positive side is a little bit warmer than the negative side. But if I look here, these are bundled cables, right? So I'm squeezing both sides. I can't really detect the difference there. So, yeah, it seems pretty evenly distributed. I have actually started the building power request last week last week? Yeah, like a week ago. So, I hope I'm in time. They did respond, and the response was, "We'll get back to you in August." And I'm like, huh? So, we might need to borrow some power from the neighbors while we're building. If we then get our own subscription in August, that's okay. August 2035, no! Okay, well, I'm kind of done with the 12 volt unit. We did like 100 amps, so 8 amps over its rated load for at least a few minutes. Yeah, no problem. No, Meanwell power supplies generally have a power good, and I also saw in the PDF that they have a power good indicator output. So the power supply will turn on internally, it'll build up the voltage, and only when the voltage reaches the correct point, so not too high, not too low, it'll enable the output, and it can immediately sustain that output. That's no problem. Yeah, I also have 3 times 25 amps here, which is fine. I also requested that for the new house. But the reason is complicated. In my opinion, it's because they have been slacking for the past 10 years and haven't upgraded the power grid, and are now suddenly like, wait, why are you guys all using more power? And I'm like, well, you couldn't have predicted 10 years ago that we would stop using gas and we're moving to heat pumps and we would stop using fossil fuel vehicles and move to electrical vehicles. You didn't see that coming 10 years ago. And then they say like, no, we didn't know. And now it's suddenly here and the whole power grid's overloaded. We can't service anymore. And then I'm like, what have you been doing 10 years? Because they've even been giving grants in those past 10 years to upgrade everything, but they didn't. So now they're very sad, and they're like, boo-hoo-hoo. And I'm like, what the fuck are you doing? And vertically, I don't know about that. Okay, let's turn this off. The fan is always running. That's an important note, though. Even when it's off. I flipped the switch. Oh. Okay. What? Let me try that again. On. Okay, it's on. Off. Ah, there he goes. Oh, wow. Yeah, I don't know, man. These power companies, I don't understand how they could not have predicted this was going to happen. I mean, yeah. Whatever you think of EVs, like 20 to 25% of all sales currently are EVs. And in respect to how much your normal home uses, your EV is going to use a huge amount. Same with water heat pumps, like the current one we have also. Yeah, they're just going to use a shitload of power. So, yeah. No, data center, I don't know. But I have decided, partially because of this nonsense, that the new house, I was already kind of planning that, but I wasn't really firm on it. The new house will run in island mode, so we'll be running primarily on our own batteries and solar. And I will have a grid connection, but that grid connection will basically be for in the winter when maybe the solar and the batteries aren't enough. And I was already kind of firm on the investment in a ground source heat pump, so not an air source heat pump. The problem is you're going to be paying a lot more upfront because the equipment is at least as expensive, if not more expensive. But you also need a well. They need to drill into the ground and blah, blah, blah. And that part alone is going to be 15 to 20,000 euros. But during this house, building the current home, I also had the same dilemma. And then we could still solderen, so we could deliver power to the grid, get it back later in the year, and we would basically pay zero. Now, I get why that's going away technically, so, I mean, yeah, that's not a problem. But then, using the ground source heat pump, I think we can offset those costs. Just, you're not paying for it during the lifetime, you're paying for it up front, right? So that's kind of the issue there. But yeah. So let me try and get these in here. I'm not too sure about that, Stefan. If you're going to live there 10 years, that's a lot of power. And currently we're spending about 10,000 kilowatt hours a year on our heat pump. Well, 10,000 kilowatt hours a year is a lot. And with the new heat pump, which we will require for heating and cooling, that's going to be a whole lot less. Yeah, and if you sell the house, having a earth source heat pump in there, I think is going to be a value proposition. It's not like something someone's going to rip out, so it holds a bit of value, right? And yeah, I still plan on putting solar in there. Of course, solar is pretty cheap right now, so it'd be, you know, stupid not to do it with batteries. And then I'm going to rely as little as possible on the grid. I'm hoping that I could do like 3/4 of the year without needing the grid at all, because the power usage will be very low because of the earth source heat pump and blah blah. And then, you know, 1/4 of the year because it's too cold and there's too little sun and stuff like that. Yeah, okay, it's fine. What is your house rated for amp-wise? Current house, but the new house also will be 3 times 25. No. The current house we also designed and built, but 10 years ago. Yeah, but is that thinking like, okay, in 10 years' time when you move, or 20 years' time, or if you're ever going to move, it's going to be 0? Because then I can get it, but... Sure, if you can get vehicle to grid, which would be vehicle to island in my case, that would, you know, give you even more capacity. But buying 60 kilowatts of kilowatt hours of battery now, I'm stupid that I bought it 3 years ago, because right now it's 1/3 of the price, and then you can get them even pre-built. So, you know, it was a good plan then. I just didn't follow through on it because of other plans that kind of got in the way. And, you know. So, LRS 1224. Let's see. Maybe. Yeah. Also permanent fan. He needs a bigger house with all the cool stuff. Yes. Okay, we're at 24.22 volts. So we went from 12.1 to 24.2. That, you know, makes sense. This one can deliver 50 amps. So we're going to dial this one back. No, not like that. To 25. And we're going to dial this one back to 25. Now it will probably still... What is that? What? The whole application's gone. One moment, please. You need to move somewhere where you don't need... Yeah, I don't know about that. Hold on, we need to wait for the stupid application to start. It's warm in Canada. Okay, well, it depends on where you are, I think. Okay, let me resize this. Is it back? What? There. It's not correctly sized, it seems. Okay, one moment. There. Good. I said, no, don't turn it on. It's 0 amps. 25. Okay. Nice. You don't like those LPS, passive cooling? I like the UHPs, but... go. Okay, not go. Go anyway. Yes. Okay, well, we're getting a lot less voltage drop now, because we're drawing 638 from the socket and 596 on the meter. I actually need to make a new data point here, because this is also not measuring fully correctly. What did I say? Right. 640 is 645. We're still calibrating the power meter. You vote Belgium. The CEO has a little room in the basement. I don't know, man. That sounds kind of sketchy. Okay, let's enable the other one. Of course I count in Celsius. What else? So let's calculate this. We're doing 597 times 2 divided by 1280 about. That's 93% efficient. Now, that still includes a bit of cable loss, not as much as before because we doubled the voltage, right? But that's very efficient. Very nice. So I need to make a new measurement again. 278 is 1290. Yeah, it was nice and warm today. It was a good day. It's running cooler. Is it? I don't know. Well, the cables are running cooler, that's obvious. It's a bit hard to say. I think it's running a bit cooler, yeah. Let's see if the hot spot underneath it, yeah, it's a bit cooler. Yeah, we're heading towards overheating of the MOSFETs again. I need to see if I can maybe do something about that. I'm not sure. But I'd say this is working pretty good. Kind of expected, you know. But then again, that's why we test things. Oh no, overheatings. I was going to say, that's why we test things. Even if you expect it to do well, that doesn't mean it isn't actually going to do well. Maybe at some point Meanwell thinks, we've cashed in enough, let's degrade the product quality, keep asking the same prices, and everyone will buy it anyway, because, you know, we've got the reputation now. That's what a lot of companies, in my opinion, in America are doing right now. Someone builds a great product, they buy it, they strip it completely and make it shit, but then they get enough profit from it still when having bought it, that they made a profit. Even though they ruined the company, they made a profit, so all is good. Except, for us consumers, this is a really, really bad practice. But then the companies are owned by the people who are rich and then get richer, so they don't really care about the consumer experience. They got more money, so all is well. I don't understand that philosophy myself. That's why I don't do those things, but yeah. Good doctor, you are in Holland as well. Yes. You like surprises, keeps things interesting. Sure. It outperforms. I don't know. It does stay cooler. That is true. Why is there a bump here? Or is it the power supply? Oh, the power supply is a bit wobbly. Is it my desk? Let me check. There's no wobble here. Okay. Maybe over here? No? Still wobbly? Over here? Still wobbly. I think it's the power supply. Can we see it? Maybe one of the fans is actually sticking out slightly. Oh, hold on. If you look at this right fan here, it's sticking out slightly past the edge, isn't it? And this one is inside of the edge. Huh. Okay. Bang it with a hammer. No, it's okay. I'll live. Okay, let's turn this one off and keep going. Oh wait, I turned it off, it's still on. Now it's off. Wow, that takes long. Let me see how long it turns to take off when I have a load on it. Okay, it's on. Let's enable the load. Yeah, good. Immediately does like 25 amps. All good. And now let's turn it off. Click. Yeah, okay. No, it's still fanning. The fan is just delayed. Delayed fan. It's off. Yes. No, well, I was just giving an example. These Meanwell so far are performing great. They have active PFCs, which is great. They have remote turn on, which is fully compatible with all the Quinn LED boards, in theory. We can actually test that as the last thing today, which is great. And, yeah. Do we want to test the last one? Yeah, okay, we want to test the last one. And we're going to do it at 55 volts. The power meter is stuck. No? Oh, it is. Well, it's off. So, Home Assistant is probably a bit confused. Come on. The UHP, I believe some have it, but not all. But in the LRS range, you know, same thing, because this one has it, but not all. And then the way they do it also differs. And from what I just read from the PDF, the way this way does it is a good way for, well, the Quinn LED boards, for instance. So, okay. You should put them in the terminals on the left side of the screw. Why? What does that make difference? Okay, so minus. Oh wait, turn it around. Minus. Minus. Yep, that's solid. If they touch the screw, they are pulled in. Okay, sure. This is, you know, that's not going anywhere though. Come on. Squeezing it in there. I am going to order some screws and then test that out with a Power 7 HC, because that would make a very, very nice combo. Okay. Let's give that a tuck test. Okay, that should be fine. This is also a 48 volt supply, so we're only going to be doing 25 amps. So having 10 gauge is kind of overkill here. Let's see. Ground of Earth, neutral, live, minus and plus. Yeah, okay. Sure. Okay, we're seeing 48.3 volts. I would have expected 48.4 volts if they follow the same, 21.1, 24.2, 36.3, 48.4. I don't know. Well, we're not able to do 600. We can only do about 600 watts, but then 500 sustained. So let's do 13 on this one. No? It doesn't want to do 13. It's mad. Oh, I didn't hit enter. Nope, it's like, nope, that's way too much, man. Okay, let's do 12. The interface is stuck. Yeah, I know. 12. 12. Go. Okay. And let's go to the other one. 12. And we're off. So, okay. 1200. Yeah, okay. Now we're going to have even less voltage drop. Yeah, we're still measuring 48.14 volts because we're only doing about 10 amps per cable. Well, we can calculate 577 times 2 divided by, I'm reading 1226 on the best meter, 94.1% efficient. That is very good. So let's calculate this to 1213 is actually 1225. So I can calibrate my, sensor better. Yeah, I can feel the heat again. I mean, intelligent fan for this one. It's always on, and it sure gets a bit louder when there's a high load, when you're asking like all the load. But yeah, don't buy it if you expect a quiet fan. That's not what this is. This is 1200 watt in a very small package, which is very efficient. 94% for the 48 volt version, or probably around 95 if we discount all losses and stuff like that. Very high. Active PFC. Yeah, good cooling, just not silent. Cool. Let's look inside. Sure, we can open one up. Let's wait for the testers to overheat. Yeah, always on fan with 9 watt idle power. Yeah. Okay, as the last thing today, we'll hook up that power function and see how that does. And see if it turns the fan off. That'd be nice. And what it does with the idle current. Do we have a big next to here? Yes, I think so. Okay, we have a dig next to. And we're going to need this little wire here, which plugs into here. And this has all the leads we need to connect to there to enable that function. Okay, the testers are starting to overheat. Okay, it's not happy. Okay, this one's off. Let's turn the other one off. There. Okay, 48 volt supply. Also perfectly fine. Let me keep the load on while I turn it off. So I turned it back on again. Okay, it's fully loaded. So we're doing... let's wait for the power meter. The power meter crashed. Oh, there it is. Okay. Yeah, nice power factor. Okay, now let's turn it off. Yeah, you see the light going off immediately. Fan's still running. But I believe the light is the power good function. So that's good. Okay, let's disconnect all these wires. Yep. We don't need the load testers right now. We don't need this right now. Well, they do change speed. So, how is this constructed? Okay, it seems this top plate can come loose. So they do change speed. So it's not like it could be DC regulated, but so there might be PWM. They just have forced airflow all of the time, basically, right? And I mean, that's different from the LRS-350 or the LRS-600. Okay, maybe, I don't know how electrically insulating these gloves are, but let's put on some gloves. And in theory, I just drained it, so, you know. Okay, easy. There is a 3M sticker here. I thought they left the protective film on it or something, I don't know. Okay. Let me disable all the overlays real quick. I guess I need to disable myself too. There. Okay, so we have the input terminals here. There is a fuse here. I'm going to turn it around because I can't read it. There is a fuse here. A T15A. 420, 300, 277. Okay. Don't know what that means. Sure. Then there's some filtering here, because there's some caps, some inductors. Or some coils at least. This might be a relay. Is that a relay? 277. Not sure what that is. Okay. You can see some big chunky transistors down here. Nicely shielded. That's good. Then we have some transformer. Oh, it's actually, this looks, if you look here, see how the board's all shiny? Especially over there. It looks like this board, there we go. This board might be conformal coated. See that? See that over there also? Nice. Yeah, the goo is, it's actually hardened pretty well. That is to make sure these components don't come loose in shipping and stuff like that, but also to prevent them from vibrating. And like these fan cables, Yeah, that's just to hold them in place so they don't go where they shouldn't go, basically, or touch something they shouldn't. But it's also sometimes to prevent or dampen vibration of the component itself, right? So you've got three transformers actually, some really large capacitors. What kind of 330 UF, 450 volt, I think, 105 rated. Okay. Noise. We see some pads here. Not sure what that's for. Maybe for cooling, because there's no silk screen there. We got a bunch of capacitors here for the output stage. That's probably why it stays on that long. Lots of vias, some resistors. Yeah, some ICs over here. Yeah, it looks really well built. Looking from this, there's also plenty of isolation between the AC and the DC side. I'm no AC power supply expert, so please, you know. Someone lost their chewing gum. Yeah, maybe. So what are these? Samsung. Okay. Can't really read the value. 270 UF, 63 volt. Well, you know, this is the 48 volt version, so 63 volt is good. It's nicely, you know, it has some headroom there. I don't know what those pads are for. Maybe for cooling? I don't know. They're also over here. Yeah, and as I showed you before, those terminals, they're basically planes on the PCB. Trying to get it to focus. Nope. They're basically planes on the PCB. They screw those terminals in, and then they solder them too, it seems. And that has to make a really good bond. It's probably some production process where they get screwed in while soldering. I don't know. Is it soldered? I think so. Might actually not be soldered. It could be friction, but I don't know. I'd solder those. I don't know. No clue. Don't know. But yeah, Meanwell LRS-1200. Tested the 12 volt, 24 volt, and 48 volt, and they seem to adhere to the specifications perfectly. Okay, let's close it back up again. Let's replace those fans for Noctua. No, I did feel how much air they were putting out. Noctua's would definitely put out less air than this. So I'm not sure that's going to be... under 40 degree fan off. Well, you saw me turn them on, all three of them, with no load. And all three of them had the fan spinning. Sure, Heckamoose, with my controllers you can count on 5 meters up to 10 meters generally working fine. Other controllers I can't really vouch for. And if you're trying to extend after an LED, then I would recommend using a data booster, because then you can go those same lengths again. Right? Okay, let's take the, I don't know, the LRS-1200-24, Wait, did I also turn off the YouTube chat? Oh no. There. And connect the AC side again. And then see if we can use that power supply function. Right? That's interesting. Okay. I guess we don't really need to connect anything. Let's connect this guy. Do I have some strip here? I do have some strip here, I think. Yeah. Okay. We'll connect some strip. Then I need wires for the. I need fork on one end and ferrule on the other. No. What kind of wire is this? It's just loose wire. Okay. Why is that here? Also no. Hold on, I know I have some. Is it here? No. No. This might be it. It's not. Okay. Well, then I know what I'm going to do. One moment. The old load testers, I needed this exact configuration. So we need a ferrule on one end. And does this fit? They're a bit bent. Yeah, that fits. Okay. Oh. Okay. So let's unscrew this. That doesn't fit. Hey there, Yorpy. Your Ipe. Yorp? I don't know. Sorry. Don't mean to be rude. I need another one. No. So this is 12 gauge, but that should fit very nicely in a Dig Next. Plus on the outside. So you can actually fit very large diameter wires in this guy. So that if I say you can actually run 15 to 20 amps, you can actually get a cable in there that will also do 15 to 20 amps without massive drop on there, right? Looking at you other controller vendors. Torque it down nicely. You can see that very nicely inside, all the metal's gone. Oh, I like that a lot. Then again, I designed it myself, so maybe, you know, I designed it the way I like it. Wouldn't that be a thing? If you design things yourself, you design it the way you like it. Okay. Okay. That's connected. They do grip nicely. That looks good. Oh wait, we need to connect an LED strip, but that's pretty easy. So we have a Quinn LED strip here, and let's put that in here. That is true, Philip. That is true. Then again, I think we agreed on most features. Yeah, it depends a lot on how much power you need, Nicolab. Because analog strip doesn't mean much. They can use 5 watts per meter or 35 watts per meter. Oh yeah, no, yeah, you shouldn't run these on the roll. I'm going to do this quickly now. I mean, that's not going to be a problem, but they will definitely melt your roll. How does this work? Yeah. Maybe I should put more warnings about that, but that will definitely happen. Do I have a block? Oh, I have a block here. Okay. Let's use a little Wago. And let's quickly look at that PDF again. Oh, one thing. Last time we used these power meter things, I automated that it would move its process to certain cores with Project Lasso. Process Lasso, I guess it is. I need to check if it actually did that. I think so. Yeah. I can see it in the usage. Yeah. I think it balanced it. Yeah. Pro balance, temperature, lower process. Yeah. Good. Yeah, because I have a 12-core Ryzen in here, a 5900X. So I have 2 times 6 cores. So I dedicated 6 cores to OBS on the first CCD. And then all these measurement applications and stuff like that, I moved over to a dedicated core on the second CCD. Right? So this A-Torch crap, which uses a bunch of CPU, I gave it 2 cores on that CCD. And then the other tools, I also gave a dedicated core. So even if I run them all at the same time now, it's fine. Because it's not overloading a single core, right? So let's give this yellow in the middle. And then blue for ground. And now we need to look at the PDF. I think I still have it open. Right. Let's see. PSU can be turned on/off by using remote control function with external switch and auxiliary power. Anyway, the 2 right pins here, the left one should be ground. Okay, that's our black wire. So that's our black wire from our DigNex 2. And then the other wire should be plus, which will be 5 volt always. Doesn't matter if we put 24 volt in. So that should be the most right wire. Okay, we need to strip that a bit. So we have that over here. Okay, let me turn this off. So let's strip these two wires. Okay, that's one. They're pretty thin. They don't have to do a lot of current, of course, but you know. Okay. So then the left one we said was ground. So that's going into the, let me put the red wire in here too, doesn't matter. Okay, so the left one is going into blue because that's where our black wire is. Okay, give a little tug test. And then the most right wire is going into yellow because that's where our trigger wire is. And then we also have red, which is a permanent 5 volt, but we want the switchable 5 volt, right? Okay, so we have our LED strip, we have our power supply, we have it connected like this. Now in theory, this setup still isn't going to work because once the power supply turns off, well, the controller also turns off. I am no stranger to melting plastic spools. This is correct. So let's turn this on, see if it even turns on, because it'll start outputting 5 volt and then it'll turn it off. So in the sheet it says power on is 0 volts, power off is high voltage. So in theory, if I now turn this on, it'll turn this, it'll immediately turn it off. Yeah, we're going to use the USB-C connection for a second power supply, but I just want to see what happens. So we turn it on. Yeah, now it just starts rebooting. Which makes sense, because then the controller turns off, and because it has no way to stay online, right? So let's use a USB-C connection as a second power connection. You shouldn't do this with other controllers, but the Quinn LED controllers are designed to do this actually. Okay, so now the controller is online and it's enabled this output. You see the fuse issues here, but that's because the main power supply isn't there and the outputs are enabled. That's kind of, you know, a circuit thing I couldn't fix. So in theory, if we now turn the power supply on, it'll stay off. Because this one's outputting 5 volt to this guy, telling it to be off. Now I need to check if I can actually find this guy. Maybe. Let me check. No, that's not the right IP. No, I don't think so. Let me check on my phone. We have confirmed that even if you turn the power supply off, the fans don't turn off, which kind of sucks. Okay, yeah, we see a... hold on, I need to see myself. We see a Quinn LED AP, so we need to connect to that. I think this one has a changed password though. Yeah, it doesn't like the password that's on there because I took this to a fair and I didn't want it to have the default password. So I probably have to, oh, okay, forget the default password. Sure, forget network. Okay, Quinn LED IP. Okay. Okay. We are connected. Good. And now we basically need to invert how our relay is working, because otherwise it's not going to work. Now, the Dignex 2 uses the multi-relay mod. And I believe the first one, so pin 5, focus, there. Pin 5 is the first output, so the AC relay output. So I'm going to change this to active high, save. Power supply turns on. Do we get LEDs? Maybe? I'm not sure what's configured. Yeah, that's perfect. Oh, wait. I configured the... Okay, yeah, I need to change the GPIO. I put it in a different output. So you have data 1 and data 2, and it's GPIO 2 and 4. So that should do it. Okay. So let's lower the brightness a lot. Let's make it do an effect. Blend. Okay, let's get the power meter in here. There. So it's now currently doing LED effects, because if I turn up the power, hello, there, we go to 70 watts, because this is a really bright strip. And you can see that on the power meter, right? Okay, and now if we turn it off, it dims down slowly, but it is dimming down. Nah, it's off. Okay, that is a really neat feature. So you don't even need a relay anymore. You can just use a USB-C for secondary power, right? Some, I don't know, cheap USB-C brick, that's fine. And then this pigtail is included with the Dignex 2. You can either solder it together or some wires or just a Wago like I have here. And then you can have, yeah, then again, 6 watt idle or 7 watt. On the other meter, I'm seeing about 6 watts, so it'll be about 6 to 7 watts. But yeah, that stupid fan that's running is probably, you know, eating up 2-3 watts. So it's not going to be silent. And it's going to, you know, still do a fair amount of watts. So yeah, let's see if we can turn it on again. Yeah, instant. Well, let's keep this on screen. We'll make it a bit brighter. Do a different effect. I don't know. Okay, let's turn it off. Takes a little bit for the LED to dim. But it does work. You can see the power usage go down by a lot. And I mean, this is now being fed by USB-C. So that's getting standby power from USB-C. And yeah, that if you have like 1,000 or 2,000 LEDs connected, going from 40 watt idle to 6 or 7 watt idle is still a big jump. I don't know. Let's do some other effect. Color loop. Ugh, so bright. Okay, color waves, sure. Yeah. So if you're in a situation where you need a lot of power, this is a very nice power supply. But if you're in a home setup and you need something quiet or really efficient when you have it off, that might be a different scenario where this doesn't make too much sense. But I like the functionality and the active PFC and how efficient it is, so it doesn't really get too warm, and it can easily deliver the rated output power. That's very good. Yeah. It works well, so that's good. You have 3 DIC next 2 and the audio doesn't pick up so well. Interesting. Do I have audio enabled? I guess so. Let's try an audio effect. Hello. Well, this is a noise meter. Is it too sensitive or not sensitive enough? Or what's going on, Matt Solomon? A dead short. We did that last time. I mean, you can do some noise fire. Also works pretty well. Not sensitive enough. I had it in my living room about 1 meter from the Sonos Era on loud and didn't react to any beats. Oh. Okay. Well, there's a fair amount you can configure. So if you go to Control to User Mods and then scroll down to Audio Reactive, you might want to change the scale, which is currently set to energy by default. You can also set it to logarithmic loudness, so that makes it react to the bass a bit better. You can do some auto gain control and set it to vivid, which will also make it automatically set the gain and be more, energetic. And yeah, you can work with the squelch and gain and the dynamics and rise and fall times and stuff like that to basically tune how well it reacts to the setup you put it in, basically, right? These are just the default settings. There's one effect I really like. What's it called again? I believe graph frequency. Yeah, sure, no problem. Yeah, it doesn't show too well on camera, but oh man, that's bright. Okay, let's turn it off. It's funny now also the behavior of the status LEDs. So here's the blue one for the outlet or the relay outlet, and now this one. It's also changed, so that's cool. Yeah. Oh, way too bright. Okay. Well. Cool. Okay. Okay, I'm gonna turn this off. I have to wait for the fan to turn off again. Okay. Nice. Well, I think that was interesting. Maybe just because I like testing these things if they really live up to the specifications so that I can recommend them to you guys. In my book, the LRS-1200 is definitely recommended. It might be a bit more suited for a professional installation where noise and stuff like that isn't too big of a problem. Instead of a house. Then again, if you have a dedicated equipment room or something like that, noise over fan isn't too big of a problem. But it really depends on the setup. You're running 15 meters of them. Wow. Yeah, they're very bright. They're almost too bright, but, I like them a lot too. They're really great. No. Did we confirm 55 volt? No. I guess we can do that real quick. Let me get this out of the way. Sure, whatever. About to use a bunch of your controllers for a charity race wayfinding curtains. Oh, okay. 48, yeah, we want 55 volt because then we can use it with diff power if it ever releases. It should. Still working on it. 6 dig next 2 and 8 dig to go. Very nice there, Rick. Rich, thank you very much. That is appreciated. Okay. We don't really need an output right now. We do need the multimeter. Nope, wrong one. So let's get the multimeter here. No. One moment. Okay, we've got some DC voltage. Do we have the overlay? We do. It's on the left nowadays. Let's see. V minus, V plus. Did I do this right? Yes. Let's turn it on. Oh, it went to 24 volt first. Well, that's probably my meter switching modes. Okay. Let's see here with the little knob. I need to find the correct... Will this work? Yeah. Oh, I already turned it. So let's see how low we can go. So it doesn't want to move any further, so we're at 46.4. Okay, so that seems to be the lowest. Oh, wow. And we can go up to 57.5. Now, I would want around 55 volts. It's very sensitive. Yeah, something like that would be perfect. Okay, so it seems to be able to do 55 volt. And generally speaking, with Meanwell, you can still do the rated output power, so that's good. Yeah, very cool, very cool. So let's set it back to 48 to not have any surprises. $48.2. That looks fine to me. Spikes with load shifts. It depends on how well it does a load shift. I don't know. Well, should be okay. We saw that it had 63 volt capacitors, so... You're running those a bit closer to the limit, but then again, with electrolytics, that's generally okay. Okay, very good. I like it a lot. Wait, let me put this back. Okay, well, very nice, very nice. Now, I didn't prepare any secret today. I worked on redesigning some boards and resubmitting them to some lab tests. I'm hoping to get the results for those in about 2 weeks or so. So that kind of took priority. Yeah. Yeah, exactly, Philip. Cool. Okay, let's turn this one off. Yeah. What do you guys think about the Meanwell LRS-1200? It kind of sucks that it has the fan spin on idle. It would have been better if it didn't have that. Yeah. I'm waiting for you guys to reply what you think about the Meanwell LRS-1200. That switched. Oh, that's a good one. We tested that last week. Yeah. The IC I replaced still worked as good as before I replaced it. So the IC replacement was a success. The only downside is that it didn't fix the problem. So they have an RS-232 in there. It's not RS-485 as I thought. And I believe the RX or the TX is blown. And it's still blown. So there is a different problem with that switch, which is not that IC. But at least what we did worked. So that's not bad. Yeah, I think everyone fell asleep, Philip. But that does mean it's probably time to end the stream. In the US, so that's okay. Oh, it takes you a while to respond? No, what? Don't like the fan keeping on. Yeah, that is the biggest downside from every testing we did today. It kind of did everything perfect. Except that fan that's always spinning. That's unfortunate. Oh, you just got up. It's 9:30 there. Nice. Yeah, it's either some other component in the line. I saw some inductors or ferrite beads there. Or indeed it went through the RS-232 IC to the MCU itself, and then, you know, you can forget it to fix it. But yeah. An XTR? What's an XTR? Is there a Meanwell XTR? Oh, there is. Okay. Oh, it's a Dinro. Okay. Cool. Well, I think I'm also going to call it a night. So, yeah. Thank you for going on this journey with me to test the Meanwell LRS-1200. I might cut this video up and make it a live stream up and make it a video. Last time that did pretty okay. And yeah, thanks for testing with me, and see you guys back next week for a video, another live stream, or maybe on the Discord server. Thanks, guys. Bye-bye.